Hi everybody. Slightly new setup. So my old Linux laptop is on its last legs. Yeah, I make games with a friend of mine, and last week the friend of mine had been looking in on my streams and told me that, well, what he noticed is that I wasn't crackling when we were working on my headset, and it was crackling during class, and it's because when I work on making games, I'm on my Windows machine, and when I was in class, I was on my Linux machine. Anyway, so my Linux machine is out, and I'm working on a Windows machine. So hopefully the video quality is much better. The main thing you're going to notice is that I have a mechanical keyboard on this machine, so you'll probably hear the keys clacking a little bit when I type. But I don't have to wear a headset, and my ears were getting tired of that anyway, so I'm glad you're all here. For those of you who were able to make it, I know life there in Northern California has been a bit crazy of late. So that one over there is a tube amp. It's an old Reverend tube amp. The Fender is just a cheap sort of bass amp. So yeah, that's true. Okay, so I'm glad you're here. I hope everything is okay, and if things were disrupted for you over the last week, hopefully things are starting to settle down. So we'll just get into it, I guess. So we are in week 4 already, which I don't know about you, but for me it seems like it's been going fast. So I'm actually pleased with that because I like it when it feels like I'm going fast. So let's see who's here. Baby Doll, hello. Daisuke, hi. Elemental Yosh, First Killer, Glazer, Little Peeper, sorry. Hi to all of you and everyone who might be watching. I'm glad you're here. I'm glad you're keeping me company. Okay, so where are we at? Let's look at where we're at in the semester. So we are in week 4, and the heads up about that is that the individual project is due at the end of week 6. So if you haven't started on that, sooner than later is a good time to do that. Tonight, we are talking about structs, and structs is one of the ways that you can satisfy one of the major requirements of the project. So after tonight, you should be fully armed to go into the project. Hi, Daisuke and Baby Doll. So anyway, keep that in mind. You should start working on the individual project soon. When it's time to start thinking about the team project, I will call your attention to that, which is sooner than later, but for now, this would be a good week to start looking at the first individual project if you have not done so, and start thinking about how you're going to solve that. So I'm just going to click on this and go look at what week 4 has in store. Okay, so we're going to create a struct, and then we're going to implement functions that manipulate the struct. So if you come from the Go language, you know what a struct is, because that's really the only way in Go to do what we're doing this week. If you come from Python or C++, you may not have seen a struct. Even though we're in C++, you may have been taught classes instead of structs. Structs are very, very similar to classes in C++. They're so similar that sometimes it's hard to tell the difference. If you come from a language like Python, then you may have seen a class, and structs are very similar to classes. Turns out the C++ has both structs and classes, whereas many languages just pick or choose one or the other of those two things and stick with that. There's a new sort of technique that I want to show you tonight for this week, which is output string streams. If you've been in the Go class, then this is kind of like formatted strings. When we do the formatting of strings for display purposes, this is kind of what this is in C++. Okay, so we are on chapter 6 in the book. Hopefully you're finding the book okay. I think the book has very good coverage of these things, and I also think it's useful that you're seeing more than just and hearing more than just my perspective on how all this stuff works. In C++, there's usually 1,000 different ways to solve every problem, so my preferred way happens to be one of them, and hopefully you're seeing some other options in the book. I'll come back to the lab assignment after we step through all the module components. So just like last week, we're going to implement some code and we're going to have a unit test attached to it. So you'll click run and you'll either pass all the tests or you will not pass some of the tests, and your task, of course, is to pass all of them if possible. What are we talking about? So this week, I'm just kind of encouraging you to get into Piazza and kind of use it as a tool to help yourselves and each other. So this week, I want you to just focus on your struggles and successes with the work that we're doing in lab this week. Ask questions if you have them, if you know the answer or you think you do. Share an answer. Oh, that's good to know, baby doll. So at least one person thinks the book is awesome. Not everyone has paid for the license, and I know it's not a small amount of money, but the book I used to use has gotten up to, I think, $150 now. And if you look carefully, the CSCI books is actually 2 books. So I've actually combined 2 of their books into one. So there's a lot of content in there. In the CSCI books. Okay, so that's the... Oh, there's 2 prompts. Questions and answers for this assignment and questions and answers for the first individual project to get you sort of thinking about that. No. So Daisuke asked, do you have to post to both of these? And the answer is no. Just post to one or the other of them, and when I go next Monday morning and check, I'll look in both and I'll just check you off that you appeared in one or the other discussion. So you only have to contribute to one of these discussions. You're of course welcome to contribute as many as you want, but just one is adequate. Good question. And then the reminders. So the team project, I guess I do have a reminder about that. So my wife teaches at Butte, and I had her add me as a student to one of her groups because there was no other way for me to see what it looked like for you when you've been added to a group. So I'll come back to this at the end of the team project and show you that I put a link in there and then give you a couple tips about getting started. It's relatively small, so you want to get started at some point, but if you don't get started this week, that's not a big deal, but we should start thinking about at least communicating with our teammates on that project. Okay, so the lab. Now I'm actually going to start with a blank screen and just talk about how structs are created and what you do with them, and sort of build up to the stuff that you're going to want in the assignment itself. I'm going to go ahead and pop up the tab for the code because I'm going to steal a little piece of it. And let me pop up the tab for doc test and I'll steal a little piece of that. So let's go do some REPL-ing. So I'm going to create a new REPL, C++. Not all of you are in the habit of changing these names. Highly recommended, because if you keep letting REPL add these goofy names to your REPLs, then you're going to think to yourself at some point, oh, we did that in Lab 5, or I'm going to say to you, hey, that thing you need to know this week is in Lab 5. You already did an example of it, and you're not going to know where Lab 5 is. You're going to think, well, which of these crazy named things is Lab 5? So I highly recommend that, and not everyone is doing this, I highly recommend that you change these REPL names so that you can find your old work. You're going to need that. Yeah, exactly right, little peeper. I mean, I've done this. If you haven't done this to yourself, then I'm trying to save you the trouble. I've done this to myself. I did something that I thought was clever, and then I let it have a default name in REPL, and I couldn't find it. But I promise you that I'm going to refer to old labs in the next many weeks to come. And if you can easily find the old labs, you're like, okay, there's Lab 5. I'm going to go grab that because he said there's something I can use from that. So if you're not in the habit, highly recommended, or you're going to just make yourself miserable hunting things down. Okay, so I'm going to start with a main. And then I'm going to replace it with the unit test because I do want you to see how I actually create unit tests. But let's start with the main and start talking about structs. So most of you should know something like a struct or a class where you create instances or objects. So I'm just going to call this a, what am I going to call it? I will call it food. I hope this doesn't torment anybody, but like my dinner time comes after class tonight, so I'm starting to think about food a little bit. So why not program about it and torment myself? So anyway, I hope that's not designed to torment you. I think it's right. I think that these are brown. That's the ones that I like to game on, but actually I like programming on mechanical too. Yeah, highly recommend mechanical keyboards. It's a joy to program. If you can afford it, try a couple of different settings, but I tend to like the heavier ones. Although this one, I like this setup. This is a Corsair. Okay, so structs. Structs are, in a sense, they're custom data types. So you're actually creating a thing that becomes a data type from which you can create instances. So I'm talking about dinner, but I'm, probably going to make a donut. So I just want you to notice when you declare a struct, now it has no contents right now, so it's just a label for a data type. But you can use that then to create instances of that data type. So donut is a food. It has no data associated with it, but this is a legitimate program. I can run this. It'll compile. It just has nothing to do. So now let's give it a little bit of data. So really the whole point of structs is because you imagine multiple variables that are all related to each other. So like I want to represent an item of food in my program, and it's going to have multiple variables like the name of the food. I better put an include for that. So the name of the food is going to be one of the fields of the food struct. So now all of a sudden donut has a name. And the way you access the fields in a struct is the same way you do it in Go, and the same way you do it in most languages, barring pointers, but we haven't gotten there yet. So give it a name. Remember, I put the using directive up here so I could do couts without the std : on the front, and also the end lines, the NDLs, without the std : on the front. So now I'm actually using, so I'm taking my donut, which inside of it has a field called name, so I use the dot notation to access that field, and then I can do things like assign data to it. I can do things like print that data out. Anything that you could do with a string, I can do with this name. It's just that this particular string happens to live inside of a food. So to get this particular string, I need to have a food to get it. So I'll also should do something I don't actually have a donut. I should have said I want one of those too. And the point here is to recognize that the way I've defined the food struct, this data type, means that every instance of a food, like donut, has a name, like burger has a name. So each of them gets their own copy of that field. What else can I say? Actually, we could do something like the calories, which would probably never be negative. And we're going to live in fantasy land, pretend like it's not many calories. I think I've talked about this before, but there's other ways to do this in C++. I just think that people, when they first see this, this is one of the easier ways to learn it. This is making a positive only integer. An unsigned integer cannot be negative. Oh yeah, I can have a quantity. Probably I can make that an unsigned integer as well. I could give it a price if I wanted to. So now every food item, every food instance has a name that's a string, a calories that's an unsigned integer, 0 and higher, a quantity that's an unsigned integer because it can't be negative, and then a double, a floating point that's a price. And then I can, like for my donut, I can give it calories. I'm sure it's higher than that, but what are you going to do? Let's just say we have one of those, and then we'll say 75 cents, something like that. So I think, yeah, it does depend on the size, which I could add that as well. So I think everyone kind of gets the idea. Whatever I want a food item to sort of be, in terms of the data that's associated with it, I can just add those to the struct, and then every instance of the struct, I have those fields in it. So let me do burger, and then I'll get up to my next point about this. So this is Fantasyland, remember, so burger's only 150 calories. I don't have any of those. I'll make those $1.50. So my outputs right now only show the names, but we'll come back around to that. So I'll run that just to make sure it's compiling. So I have a glazed donut, I want a hamburger. So hopefully you kind of get the point about the struct. Okay, so you're going to see this next week. You're going to see something different than the way we're doing it tonight. But for this week, so that you are prepared to handle the lab as I've created it, I want to set this program up very similarly to the lab. So one thing that you should be doing already in your programming work is whenever you see highly repetitive code that makes your program messier and messier and messier, hopefully you're starting to think to yourself, maybe a function would help with that problem. So I'm actually going to create a function below the struct here. You're going to see something different next week, but I'm going to create a function below the struct, and I will call it init food, as in initialize an item of food. I'm going to pass in some food, I'll call it F, and then to initialize it, I'm going to give it a name. I'm going to give it, this is going to go up pretty far out there, calories. I'm going to give it quantity, and I'm going to give it a price. So I have this whole function where I'm going to pass in a food, and then I'm going to initialize that food with all of this stuff. So this has come up, actually it was a really good question in Piazza. Like, if the parameter name is the same as a name inside, or like as a part of the struct. Now this is an easier one than the question you asked in Piazza. That one is a more complicated one. But in this case, hopefully everyone can see that the way C++ can differentiate between this name over here and this name here is this name is attached to a food. So this name is a reference to the name that's inside the food struct for this food called F. This name, since there is no other name here, has to be this one. And we're just going to go down the list. Calories equals calories, the same thing. the calories inside the food. That's what the F dot does. And then the calories, the only other one that C++ could refer to is this one right here. And then I'll hit the quantity. And I will hit the price. And then I can change this stuff down here. And sorry if this is off-putting the way I do this. So I'm going to pass in the donut this time, and then I'm just going to grab, by deleting, I'm just going to grab the other pieces of data so I don't have to retype them. Also, this will slow me down a little bit, so if you're working along with me, there's a good chance you can go faster than me at this stage. Okay, so I want you to see what I've done there is I've passed in donut, that's my F. I've passed in this name, this calories, this quantity, and this price. So in theory, at least, donut's going to get this stuff. And we'll just test it with name to see what happens. And then it's kind of a quiz question. So I'm going to just slow down a little bit here in case anyone's typing. I know I went fast, and make sure you have a chance to try it if you want to try it alongside. Let me push this down a little bit. Okay, I'm just making sure that you can see the bottom of my screen, which I think you can. So I have a struct, and then I have a function that, at least in theory, is designed to allow me to do manipulations on that struct. In this case, take the struct and load up all its fields with some specific data, which is what I've done here. So let's run it and see if I get a glazed donut at the end. Because it should say I have a glazed donut. If you've tried it, then you know, you already know what's about to happen. I'll move this up. I have a nothing. So something's wrong. It compiled, but it did not do what I wanted. So here's the quiz question is, something is wrong with this function that it's not actually changing the donut. My donut doesn't actually get a name of glazed donut on it, even though in theory that's what the function does. So this one's hard because for many of you, the first time you saw this, okay, good question. So I'm not catching any returns. In this case, this function doesn't return anything, but you're thinking along the right lines, is to inspect the function and sort of ask yourself, what are my options here? So good to note that. This is a void function, so it won't return. So there's something else that I could do so that this function actually does change the donut. So that's my hint. When I pass in donut as F, all this work seems to be lost. So there's something wrong with the function. And a good place to start was the return value and check to see if I'm not capturing that. So, does anyone remember another possibility? Okay, so pointer, there's another word we'll use for that. You're correct, baby doll, that it is a pointer. What does that look like? There you go. So, that reference marker. So, one of these things, only one of them needs to be a reference, so that the changes are sticky. There you go. That's correct. So it's right in here. So if you want the changes on food to be sticky, is how I describe it to myself, then you need to put the ampersand, the reference, Baby doll's right, by the way. Effectively, this does create a pointer back to the original thing. The terminology we use is passed by reference. The other thing you might not remember is that that ampersand can go anywhere in between there. As long as it's between food and F, it can go anywhere. You'll probably see me do it in different places. I don't think I've ever decided where I think it looks the best. But as long as that's in between there, the F is now a reference back to the original. So when I init the donut, the function is actually going to receive a reference back to the actual original donut instance, and it'll get a name on it. So now the change sticks. So good one. That was a hard one, so you guys did good to figure that out. And I'm not joking, that is a hard thing because it's so subtle. It's so subtle. Okay, so let's change burger and we'll do the same thing. So we'll use the init food on the burger and should be exactly the same. So I'm also going to do this sort of slow way of doing it to slow myself down a little bit. Plus, I don't feel like typing all those numbers again. So I'll use the same function, but pass a reference to burger the second time, so all those changes take on the burger. And I'm going to go ahead and run it just to confirm it works, but hopefully I'm slowing down enough that you can keep up okay if you're doing that. So that's just a check. So glazed donut, check. Hamburger, check. All of those things work. All right. So good job on getting this passed by reference. It's a very subtle thing. It's very easy to miss until the moment when your program doesn't do what you expected, and then you sort of have to inspect the function. Little Peeper was smart to start with the return value and see if I had missed a capture of a return value. And then we start thinking about, well, what did we want the function to do? We wanted it to initialize this food item and make it stick. So that's what the ampersand is for. Okay, I'm going to switch to testing mode now. So I am going to scrub out some of this stuff that I've done. I'm actually going to create a file and just call it notes. So that any of the work that I want. So what you're going to see me do is I'm going to cut out all of main because I want to show you how I write the unit tests. Just so you know how they're created and you have a better sense maybe of what's going on when you run one. So I'm going to cut main. I'm literally cutting main out. And I'm going to place that in notes so that if I need it later I can come back to it. So Baby Doll asked a question, why is this semicolon needed right here when it's not on a struct? I wish I knew a good answer for that. The short answer is because that's the way the C++ language was designed and it requires it. There is a little trick you can do, which we're going to see later in the semester, because this is a bad way to describe this, but it's a little bit like a dead-ended variable name. Anyway, you're going to see that we're actually going to use the space here later in the semester. And when we do, I will point it out to you. So it actually allows us to do something with the struct, having that semicolon there that I don't think would work without it. So the short answer is because it's required. The longer answer is there's actually a feature of C++ that we can take advantage of because of that. Okay, I'm switching into testing mode. So what I'm going to do is I'm going to go to the lab 4 and I'm just going to pluck off these two lines. So this define doctest config and the include after it, I'm going to pluck those off. And by that I mean I'm going to highlight them and do Control-C to copy, and then in my REPL I'm going to put those at the very top of my main file. because I'm actually going to write a unit test so that you can see what those look like. So I need those if I'm to write my own unit test. The other thing I'm going to need is I need the doctest.h file in here. So the second step is to actually create a new file. Call it doctest.h. Be very careful that when you create the new file that you spell it exactly the same, upper and lower case and all that stuff. So doctest.h, very carefully spelled. Press enter, so new empty file, and now I'm going to go grab that. So I already popped it open. I'll slow down a little bit, but what I did is I went to the lab assignment and I popped open lab 4 and got some stuff out of it just now. And I popped open doctest.h, which is sitting right here. So there's the lab. I went to the lab for the week. I clicked on lab4.cpp and it opened in a new tab. I clicked in doctest.h and it opened in a new tab. So that's these two. And then I have my REPL. So hopefully that slowed me down a little bit to tell you that part. So I need to populate doctest.h, and I'm going to do that with the doctest.h code. So I'm being careful that when I go into GitHub that I'm in the right place. For me personally, the way I think this is easiest is from this location that has, you know, the little icons and the numbers, click the raw button. And then you get the raw doctest.h code. And then you can do Control A to copy, Control A to select all, Control A to select all, Control C to copy. And then I'll go to my REPL, into my empty doctest.h, and I will Control V to paste. And now I have a full 6,000 line copy of doctest.h. I need that in the assignment, and I also need it for the example I'm about to show you. So hopefully I didn't go too fast, but I'll slow down here for a second just in case you need to catch up. The notes file, I just created that and set aside the main that I created for you as an example for you. So I actually cut all of main out and put it in this notes file so that if I need it later I can come back to it. Doctest.h is a copy of doctest.h that's linked into the lab. And main right now is just this stuff. So it's the code that I worked on at the start of class with main cut out. And then I went to the lab 4 file, lab4.cpp, and I grabbed this define doctest line and the include doctest at the very top. And then back in my REPL, I pasted those in. So I'm in my REPL. I'm about to write my own unit test because I want you to see what that looks like when I create those things. So top 2 lines. Okay, so we're going to write a unit test. There's no main here. Doctest, because of this line at the top, actually creates the main function automatically for you. So when you're writing unit tests with doctest, you don't make a main. So the way you make a unit test with doctest is you create a test case. You can create multiple test cases if you want, but we're not going to mess with that right now. We're just going to make a unit test. What goes in the parentheses here is a description of what it is that you're testing. So I'm going to call it food test. So this doesn't have any special meaning. I'll show it to you when we run it. It appears in the output, but this is really just a description of what am I writing a test about, the food struct. I guess I could say struct food test. So that's how you set up to start writing a unit test. Then you do this. So it's almost like writing main up to a point. Well, not really. So let's make a food. I'll call it a donut again because I enjoyed that. And then I'm going to initialize the donut with some basic data. So we'll say like 100 calories. We'll say a quantity of 12 dozen. And then we'll charge ourselves like 50 cents a piece. So the first thing that you have to do to do a unit test is sort of use your code. Because the whole idea of writing a unit test is to see if your code does what you would expect it to do. So that's the setup. And now we do some testing. So we're going to do a check. So this check EQ means we want to check to see if two things are equivalent to each other. So in theory, for example, donut's name at this point should be donut. If it's not, something's wrong with my function. And we'll run that. And again, you don't have to write unit tests, but I want you to see how I create them and the thinking that goes behind creating a unit test. So I'm checking for equivalency. I want to see if donut's name is equivalent to the string donut after my function runs. That's what I want to know. And if it's not, then I got a problem. Okay, so I passed my, I have one test case, and then one, this is called an assertion. So I asserted that donut name is in fact donut. And then I'll write a few more just to see if all of the pieces of my function work. So I also expect that at this point that donut calories should equal 100. I expect that donut quantity should be 12, and I expect that donut's price should be, now this is going to look a little bit funny, well, let's just try it. Let's just see if it equals 50. Sometimes floating point values act funny, and we'll improve it. In fact, I'm just going to improve it right from the start. Floating point values don't compare very good in programming. It's the nature of how they're stored on the computer. So what you'll see me doing in your unit tests about this is I'll look for approximate values. So what this does is kind of leave a little bit of margin for error because of the way computers store doubles, floating point values. So if the donut price is within a reasonable margin of tiny error of 50 cents, then we would consider that a good test. And then I'm going to go after this and I'm going to break it so you can see what happens if something's not working correctly. Okay, so right now we're passing them all, so we're happy about that. So let's go make one fail. So we can see what a fail looks like, and if I am trying to pass a unit test, what should I do about it? So the way I'm going to fail is I'm going to comment out this price in init food up here so that that's not happening. And what should in theory happen is that assertion is going to fail. So when I check to see if the donut's price is equivalent to 50, it shouldn't be. It's not likely to be because I never did the assignment. But I want you to see what it looks like when a fail happens. Okay, so we failed, which is what we expected. But the thing to do is to inspect the failure. So it's the test on line 29. And it's telling me what it was checking. It wanted to know if the donut's price was approximately 50 cents. So here, what it's saying is the donut's price showed up as 0, which does not match approximately 0.5. So I'm failing that test. Now we know why I failed it, but I want to just give you a little bit of detail while we're fashioning our own unit test. But we know the problem is that we didn't actually do the assignment, so we failed the test. Okay, so should I do lab 4? Um, let's see how we do with this. I'm going to do a very similar thing to lab 4 so you can see the last big thing. If I go look at lab 4, init item, so now all of a sudden hopefully that looks familiar. I will do a total something so that you can see an example of this kind of thing. Yeah, and also I want you to understand what const does. So I'm going to do something that's akin to total value, and I'm going to do something that's akin to this to string, and then I'm going to write unit tests around it just so you can see how that might work. Okay, here we go. So I'm going to do a void. I'm going to do total calories of a food. That is going to have to return an unsigned integer. So this is another one of those subtle points. It's going to feel weird a little bit at first, but I want you to see C++ as people actually write it in the world. So when you encounter one of these sort of weird things that you haven't seen before, part of it is I want you to see how people use C++ so that when you see it somewhere out there in the world, the techniques are somewhat familiar to you. So we know this pass by reference. In init food, what that does is it makes it so that any change that I make to this food actually sticks to it. So you'll notice here that I don't have a pass by reference, and I don't really want a pass by reference because this function's job isn't to change the food, it's just to compute how many total calories does it represent. Oh, the show all the tests? Okay, I'll go do that real quick. So the question is, before I do this total calories example, how do you show all the tests? So the way you do that is you actually go into the terminal. So when you click run, it does /main, and you can actually do /main for yourself in here. And you do -s, which will show you all the details. That also works if you're failing. It'll show your successes and failures. So you actually go into the terminal and you manually run your program with -s, space -s at the end of it. And then you get all the extra details. Okay, no problem. Okay, back to total calories. So the reason why we do not need to pass by reference in this case is because we don't want this function to actually alter the food. We just want, basically we want to know if I eat them all at once, how many calories is that? That's how we're going to do it. So I'm just going to multiply the calories times the quantity and return that value. If this is new to you, it's okay to break it apart. So some of you might be familiar with the slightly longer hand. So I could say unsigned int result equals f dot calories times f dot quantity, and then I could return result. But since there's no complex logic here or anything, I can just eliminate the middleman and go straight to the calculation. So you can, if you want to, break it out into separate steps. But usually, for me, if it's a simple calculation like this, I just eliminate the middleman and just go straight to the return and do the calculation right as part of the return. So it's going to return that total quantity. That's what we want. And again, I'm not passing by reference, I am passing by value, which means that a copy of the food's going to be made for the purposes of this calculation, and it will work. So the way you do this, by the way, is I'll just check that when I compute the total calories of the donut, it should come back as 1200, I think. That's what I'm expecting. So again, I'm sort of taking advantage of the fact that a function that returns a value kind of is a value. So if I call total calories, that basically is an unsigned integer. So I'll just compare what I get back right on the spot with what I expect it to be, which is 1200. If I eat all the donuts, and now that actually sounds like a real amount of calories all of a sudden. The lag is doc test tag. All right, so I'm passing all those. So that does work, which means that this is fine to be passed in by value. But this isn't often the way people will do this. So here's the thinking behind what I'm about to show you. When I pass by value, meaning there's no ampersand here, so it's not actually a reference to the original, a whole new copy of the food has to be made. And at a point that starts to be wasteful of computer memory. So a copy of a donut means a copy of all of those data fields. So this function has to copy all of those data fields for donut just to do this calculation. So what you'll see people often do is, well, I can eliminate the copy, so now I have a reference back to the original. But that's not good programming style because that suggests that I'm supposed to do something to change the food. So you combine that with the keyword const, and what you get then is an unchangeable direct reference. This is just one of those weird things, again, many of the weird things about C++. A const reference means that no copy is made, but no changes can be made, and that's what I want in this case. I want to save the computer the work of making a copy of the donut, but I want to sort of protect myself against accidentally changing the donut when I just mean to be computing the total number of calories. So when you see that, it'll take some getting used to, but you think to yourself, oh, the const means someone is trying to save the computer some extra work. Without the const, it means they want to change it. With the const, it means they don't want to change it, but they want to save the computer the work of making a copy. So I'm going to rerun the test just to make sure that it still functions properly. It will. But I also wanted to show you that so that when you see it in your lab this week, you have some sense of what it is that's going on there. The const keyword tells the C++ compiler, don't let me change this thing. The ampersand says I want a direct reference. In combination, it means a direct reference that I can't change. Without the const keyword, like we did in init food, it means a direct reference that I intend to change. And then I wrote a little unit test. I added a little assertion here to check to see that the donut computes out to 1200 total calories, which is its 100 calories per donut times the quantity of 12 that I initialized it with. I also could have done a total price one if I had wanted to, which I'm not gonna because the time is better spent on the last hard thing. So what we have here, this is just so you can see how I fashion the unit tests. What we have here is a struct that we created called food. That's basically a brand new data type. That's really a combination, a package carrying all these variables around in it. And then I've written a function for the purpose of initializing these food items with pieces of data for all their fields. And I've written a function that takes a food item and computes the total number of calories that it represents based on its quantity and the number of calories per item that it is. Alright, so now the last thing, and this last thing I use it a lot in this class. So You're going to see this same technique over and over and over again because I think it's a good and a smart technique. So this will be your first time to see it, and we're going to see it a whole bunch more times. But the last thing is I want to take all this information and I want to convert it into something that I can print on the screen that says, hey, you have a donut that has 100 calories each and you've got 12 of them and it costs 50 cents. I want to convert all that data into a string that I can then print on the screen. So that's what this last part is about. And we'll build this up in stages. So let's build it up. Not to be mean about programming algorithms 1, but if we were doing this in programming algorithms 1, there's a good chance that we would start simply by saying, let's write something that prints out the food. I'm going to do something here that you might be able to improve upon, by the way. But what does it mean to print out food? Well, let's just say, we'll see out the name, and then maybe a comma and a space, and then the calories with a little label next to that, right? And then the quantity. On hand. And then you can do this in C++, so I'm going to do it. I'm just going to leave this line up here trailing, so no semicolon or anything. No, I'm not going to do that. Never mind. And space. I'm going to stop that line and then finish it on the next one down. So I need a $sign, and then I need the price. And then I'm not going to put an inline. Am I going to put an inline? No, I'm not. So this is how we might build up to this in the first semester programming class. Like, what does it mean to print out a food? It means to print out all of the information about a food with handy little labels that tell people what this piece of information actually means. So donut, comma, space, 100, space, cows, comma, space, 12, space on hand, comma, $sign, the price. Yeah. I know, we're getting like dangerously close to dinner time where we're all going to want to get out of here. So we're going to print food. And we can call print food on donut. It's kind of meaningless to do this inside of a unit test like this because it's not really something that I can test. But I want to show you that this is a good way to sort of start the process that we are beginning to do, and also the thinking behind it. So I have a print food function which is supposed to spit stuff out on the screen, and I have a feeling that if I run this code with print food in the unit test, it may not even do it. You notice? Oh yeah, there it is. It snuck in there. Which is okay, but it's not a good way to test the code. It's just sort of sitting there. It's missing, by the way, the magic formula. Hopefully you guys have found that. I'll go show you where I find it. If you do C++ magic formula, which is why I use those words in the assignment, I like Marina's blog for this. So I go to Marina's blog and I grab the stuff that I need. So here she's got an example program, and the nifty parts are these three right here. So the set F, this is a set flags function, fixed output, show the decimal point whether or not it's needed, and how many places after the decimal. This is set to be 2. So I'm going to grab that, Control C, go to my REPL, and I'm going to paste it into my function. Now the reason I'm doing that is because I noticed down here that it says 0.5 for a price, and I wanted to say 0.50. So I'm going to use the magic formula to get my 0.50 out of it. So all of this is going to affect this price that comes out here in a second. So notice this time down here in the bottom it says 0.50, and that makes sense, right? That's what you want prices to look like, is 2 decimal places. I'm also checking to see that the spacing looks okay. It does to me. So that's step 1, is simply kind of figuring out what you would like it to look like if it were printed to the screen. The rest of it is actually easy, but conceptually it's a little bit hard to understand. So we're going to add some stuff at the top of the file. So for short-term purposes, I want to be able to actually write a unit test for this, and I can't right now if it just does couts. It's just going to print them out. So what I'd rather do is like get a piece of data, like a string that I can test, do a comparison on to see what it looks like. So here's the way that goes. We're going to have to add an include. That's S stream, so an S followed by stream. What that stands for is string streams. So I'll explain this in a second, but that stands for string stream, and it is the key to the trick that we're about to use. Okay, so here we go. Down here in this function, where's print food? Print food. So I don't want to print the food. I actually just want to take the food's data and combine it all together into one string. So I'm going to change this function. I'm going to return a string, and instead of calling it print food, which I don't want to do anymore, I'm going to call it toString. So I want to take a food and I want to toString it. I want to turn it into a string. And I think you're going to like the next part, because this is just so easy to do. I put 2 blank spaces on either side of my cout stuff so that you can see how easy this is. So what I basically want this all to happen, but I don't want it to appear on the screen. I want it to go into a string variable that I can write a unit test against. So to do that, I'm going to create one of these things. I'll call it output. So oString stream is an output string stream. It's what we want when we want to sort of do what we would have done to cout, but into a string instead. I know that's going to be confusing at first. Use an oString stream. It stands for output string stream. I'm going to name it output. And then I'm going to use it to capture these outputs. So instead of that set flags going to the cout, the terminal screen, I'm actually going to apply that setting to my string. So I'm actually going to do this whole operation in memory. It's pretty cool. So I'm going to apply the fixed to my output. I'm going to apply the show point to my output. I'm going to apply the precision to my output. And then I'm going to not do output anymore, but actually direct that stuff into my oString stream. So now none of this stuff affects the screen. It all goes into memory. So what I get in the end is my output that has all of those settings for the floating point, and it is now in memory. The last step of any function that returns non-void is to return something. So I'm going to return the output, and this is important. I have to convert it back into a regular string. So this output is one of these crazy things. This .str turns it back into one of these normal things. So the output is a crazy oString stream that I can do all kinds of crazy stuff to. The .str on it means I actually just need it to be a regular string now, please. One of my favorite tricks in C++ is to use an oString stream to take all of my data from something like a struct and combine it all together into a nice pretty string and return that. Now, what's the power of that? Well, for writing unit tests, the power is now I can write a check on it. So I can check to see if to stringing my donut gives me back what I expect, and I'm looking down here to get what I know I want. What it should do is exactly this. Cows 12 on hand, $sign 0.50, and that's it. No line break at the end or anything. If you wanted to put a line, expected a line break, you'd check for it. But I didn't put a line break, so I'm not going to test for it. So this is one of the advantages of this toString thing, is that you can now test it to see if it's actually putting the data together in the way that you expect it to be put together. Yes, so if you can see in chat, Baby Doll's asking if I can feed these settings directly into output, and you can. Yes, you can do it exactly like you would for cout. So the main reason I do it this way is because I think people can find it by Googling C++ magic formula and remembering that. But what you're doing, Baby Doll, which is to pipe fixed and set precision, that works perfectly with output too. Pretty cool, isn't it? It's a pretty cool thing. So I know the concept of taking something like a struct and sort of combining its data into one string. It seems weird. Why not just do it to cout? But you're going to learn as you gain more experience as a programmer that you don't always know in what context your code's going to be used. And a lot of people don't want couts in your code because they're going to run it somewhere where couts don't make any sense. So what they'd rather have your code do is just manage data and return data, and then they can choose how they want to use the data that your code produces. So it's, I would argue, a better design is to make it so that if someone needs all of the data about your food in a string, they can get that, and then if they want to cout your string, well, that's their choice. But it also means that now we can easily test it to make sure that its formatting is as expected, which it is, and passing the test. So pretty neat. One of my favorite things. I just think that's such a cool trick. That it just works like that is magic. That's mostly it. I mean, and by mostly, I mean that's probably it. So that's all examples. Of course, you have an actual lab. I believe, so I called it out over here, but this is lab 4, so I did an example of that. I did a total calories, an example of that. Reducing the quantity, and you can see it's being passed by reference, so that means that you're going to change the object. Increasing the quantity, notice it's being passed by reference, you're going to change the object. I did forget one thing. I can make an improvement on this line, and then we'll call it a night. So I can save the computer some work here if I want to. I don't have to, but I can if I want to. What would that look like? Where'd it go? This line right here. I think maybe I have everybody stumped. There's something I can change here to save the computer just a little bit of work so that it won't have to make a copy of that food. Because I'm not actually changing the food, but I can save the computer the work of making a copy of it when it comes in by value. There you go. So it's a reference thing. Pass by reference, and then sort of how do I, and there's one other step to do since I know, so this saves the computer the trouble of copying it, But I also should take the extra step because I know that this function isn't actually changing the food. It's just printing out its values. So what else can I add? There you go. Good one, Tyler. So all that does is save the computer the work of generating a copy, so it's a reference back to the original. But the keyword const is really a signal that I'm not changing the food. I'm not using an assignment statement here anywhere. So I'm sort of covering my bases by saving the computer work and making sure that it's clear that I don't intend to change anything here. I just I would like to have the sort of cheaper reference to the food and not a brand new copy of it. Cheaper in terms of work that the computer has to do. So that's how you would often see people set this up when they have a struct going into a function. Now that's tricky, right? When do I put const and when don't I put const? For the most part, on the labs, I will have set it up for you. So really, I would just say pay attention. Keep your eye open for where you're seeing things being passed by reference and when they're not being passed by reference and when they're being passed by reference as const. Just take note of those when you see them and sort of think maybe a little bit about what the function's doing. If the function has the assignment operator in it, then there's a chance that the reference can't be const because you can't do assignments on a const. In fact, watch what happens. So if I on init food, make this food be const, I'm guessing I might get a wall of errors. Okay, I didn't get a wall, but I got errors. I got a wall. It's a wall of errors for that one thing. But we can just pick any of these. Like right here, line 18. Cannot assign variable f with const qualified type const food and f.calories. So the compiler actually did its job here. The compiler noticed, hey, you put const on there. I thought you weren't going to change anything. And oops, right now I did it on purpose, but in that case I need the const off of there or I can't do what I want. So that's your first exposure to it. It's not anything to obsess over a whole lot because I've already set up the code for you and you're just supposed to fill in functions. But I did want you to have a sense of where all this stuff comes from. Where do the tests come from and how do we write them? If you learn how to write these for yourself, there's a lot of employers who will love you for it and a lot of old-time programmers who might think you're some kind of new-fashioned programmer, but a lot of us and a lot of my friends in industry think that this is a very valuable practice. So you'll actually see people using unit testing in the real world too. So if you know kind of how they're built, I'm just giving you one way of doing it, the most simple way, but it can be useful information to have. Yeah, exactly right, little peeper. Hey, I had a teacher who made us do these stupid unit tests all semester. But one of these days, you're going to be a team lead, and I hope that you'll at least consider we should use unit tests. It's one extra way to ensure the quality of our software. Yeah, certainly I think for when you're doing the labs, the unit test is sort of your best way to know if you're doing it correctly. Is the unit test. One thing that you can do, I mean, I'll just sort of warn you that if we see people kind of cheating the unit test, which there's a way to do, we'll just overwrite the unit test with the original and test against the original. But one thing you can do is just make a subtle change in the unit test and see if that works. So if we change the donuts to be hamburgers, then of course we'd want to change the unit test everywhere else where we're making a reference to hamburger. But in theory it should be true that if I change that initialized to hamburger and a couple of other references to it, I should still pass the unit test with that change in the unit test data. Yeah, that's a good way to look at it, Tyler. It is kind of an auto grader when you're working on your own. I like them. This probably means I have some kind of minor issue that they please my sense of order to write unit tests, and it pleases my sense of order to pass them. So that's it. Our unit testing library is called DocTest. It's one of the simpler ones, and it's a fairly fast compiling one, so I enjoy working with it. There's hundreds of unit testing libraries in the world. Google has a very elaborate one, for example, and I'm sure Facebook has a ton of their own unit testing libraries and frameworks. The Go language has one that's built in. C++ doesn't have that. There's a bunch. Okay, I'm done. I went over, sorry, but I wanted to give you the full story. So I hope you have a good rest of your week. Hopefully we keep the momentum up. I'm really pleased that you guys are doing so well, and from where I sit anyway, your work's really good, and you're still engaged in the class. So if we can keep our energy up, we're already 4 weeks in. We're like a quarter of the way through already, so we're doing great. Yeah, I don't even know, little people, what is going to happen for dinner, but while I'm in here working, fingers crossed that food magically appears on the plate out there. Okay, everyone have a good rest of your week. Take care. Thanks for being here. And if you're watching later, Piazza, Canvas inbox, and I'll post these videos tonight to the various places. See you next week, next Tuesday at 6 p.m.